Now we're going to look at number 4 and maybe number 6 at the same time. They're going to be similar for the next several questions. So we're going to look at the square root of 216ab squared. So now we have variables involved. We still work with 216 just as we did before. There's actually a few different methods. I'm going to go with what I think maybe you guys would notice. And you might notice 4 goes into this. So we could write this as the square root of 4. And then you could do 216 divided by 4. You could do that on paper, or you could just do that on a calculator. 216 divided by 4 is 54. And so I'm just going to deal with the numbers right now. So this is 2, and then you might think, oh, 54 is 9 times 6. So we could do square root of 9 times square root of 6, because we're thinking of another perfect square. So this is 2 times 3 times root 6, which gives us 6 root 6. So the square root of 216 simplifies to 6 root 6. But we also have this ab squared in here. So what we're going to look at is we still have our 6 root 6, which we'll be able to do that as we go along here in the next couple. But we have the square root of a times the square root of b squared. So what we're going to do here is we're going to make 2 square roots, and we're going to look at a, and we're going to think, are there any perfect squares in a, or is there an a squared, and there's not. So that doesn't simplify at all. And next we're going to look at b. Is b a perfect square? B squared a perfect square? And it is. So we're going to put that here. So in our first grouping, these are things that are not perfect squares or have no perfect squares involved. And in the second one, we're going to put perfect squares. And so in this case, it just happened to be that a went in the first one and b squared went in the second. So we still have 6 root 6 root a, and then the square root of b squared is b. Now this is all we can do with the simplifying radicals, but we can put this in a better order. We do 6b, because they're not under square roots, and then times the square root of 6a. And that is the simplified version of that. So let's go ahead and jump to number 7, because I want you to look at something like this. The square root of 108, a to the 4th, b, c to the 4th. So what I'm going to do, we have to work with 108. 108, think what goes into 108. I actually think 36 might go into 108, which is a perfect square. So remember, I'm looking at these perfect squares. 36 into 108, so we got the square root of 36, and that goes into 108 3 times, so that times the square root of 3. Then I'm going to talk through the same thing. In this first one, we're going to put numbers that are not perfect squares, or variables that are not perfect squares. And I'm going to even break things up a little bit more here. And then we are going to put in the second one things that are perfect squares. And so a to the 4th, well, that can be written as a squared times a squared. Those are perfect squares. B, that is not a perfect square, that can go in there. And then c to the 4th can be written as c squared, and both of those can go under that square root. And so now we simplify some more. We have the square root of 36 is 6 times the square root of 3. And we're going to keep this b here. That goes, these two are not perfect squares. So 3b, that's not a 36, it's a b. And then here, we think through this. The square root of a squared is a. The square root of this a squared is a. The square root of c squared is c. And the square root of c squared is c. And so we can simplify this finally by writing 6. We have a times a, which is a squared. C times c, which is c squared. And then the square root of 3b. I'm going to go ahead and do number 8 also, because that has something that we haven't seen yet. So number 8, we have the square root of 8. We've seen that often, and we might know what that is. So we think, well, 4 goes into 8, so the square root of 4 times the square root of 2. And now we're going to have, these are our variables that are not perfect squares, and these are. So x It's just x to the first, not a perfect square. Here's the new thing. We have a y cubed. Well, y cubed is y squared times y. So the y squared is a perfect square, but then we have a y left over. Z to the fourth, that can be broken up into z squared times z squared. And so we have 2 root 2. The xy can't simplify this, so they stay under a square root. And then looking at this one, the square root of y squared is y. The square root of z squared is z, and the square root of z squared is z. So our answer is 2y z squared. That's 2y z squared times 2xy. So you should be able to use that method to do number 5, 6, and 9.